Today is the day, folks. I'm really happy to be announcing that we're going to be able to start using sCrypt here in Babbage contexts through the Babbage MetaNet client. I've just pulled down the code for the sCrypt demo project, and I didn't really change anything. So we can see the original demo contract here, which just sets up a basic sCrypt TS class with a constructor where you can pass in the hash, and then you can unlock it here with the original message and get your coins after you've locked them up in that contract with the constructor. The only thing I've changed is I installed the Babbage SDK in package.json, and then in the deploy.ts here, I just I rewrote the main function. So previously the main function was using the testnet wallet from the sCrypt, and now I've just replaced it here with Babbage SDK. So I wrote a few functions, and basically what we're doing here at the top is we're compiling the contract just like before, right? So I'll use line numbers. On line 91 here, you can see I'm just compiling the contract as I did before. And then I'm actually creating a new instance of it with hello world as the string here that we're going to be hashing. So I'm making a hash of hello world. I'm putting it in the contract, and then I'm actually deploying it. So I'm calling this deploy function, and I'm passing the instance. I'm passing 1,000 satoshis there on line 95, and then I'm saying deploy a smart contract, which is like a description, and then I'm putting it into a basket, and I'll get into that in a second. So basket, and I'm just putting it into the tests basket on line 97. So that's what I'm doing for deploying it. Then I'm logging the TXID of the deployed contract that I deployed using the Babbage SDK here with our sCrypt integration. And now I've got a transaction on the blockchain. So no private keys required, nothing like that. You just put the MetaNet client on your computer, and then suddenly you can use sCrypt like this. And so we put it into this tests basket here. So we deployed this sCrypt contract. We put it into, this basket. Now on line 100, we are going to call this list function. And we're going to pass in the tests basket. So we're saying list all of the contracts, all the instances of contracts, rather, that we've actually made that are in this basket that holds these contracts, these UTXOs. Baskets in Babbage hold UTXOs. And then I'm just passing this transformer function in here. And what this does is it takes a locking script from the transaction output that is in that basket where we put it, and it's going to just make a contract, make an sCrypt contract out of that locking script. So that way we've hydrated the locking script, and if we've actually put a contract instance associated with it. So if I hover over here, this list, we can see that that's actually called a contract hydrator function. And if I zoom all the way out, maybe it'll show on Visual Studio Code the type here of that. But the contract hydrator just takes a locking script and it hydrates all of the sCrypt stuff into it. And then that's going to return a type called list result, I believe. And so basically we're going to log that, right? And that's going to show, what are the current things that were in the, what are the current instances of sCrypt contracts that were in the tests basket. And then finally, we're going to actually redeem the contract. So once we have created a contract, we put it into a basket, we can then list it. We can see all the different contracts that we currently have, the current instances of these contracts in our basket here, the tests basket. And now we're just going to pass in from that list, we're saying const contracts equals, and we're listing all of our contracts. So we're just going to say, well, contracts sub 0, meaning the first contract in the list, we're going to pass it into our redeem function. So the first parameter to the redeem is the list element, if you will, that is all of that stuff about that. And then about the particular instance. And then we move to line 106, and what we're saying here is we're passing in this function to redeem, and it transforms. That's the redeem transformer. So it takes it takes the contract itself as an input, and it's just going to go ahead and call the function on that contract. In this case, the unlock function, which we're calling on line 107 here, with the correct value to actually unlock the contract. And if we tab back over here to deploy, or rather to demo, the unlock function is down here, and we're literally just calling this function, right? We're invoking it, and that is what unlocks and redeems our sCrypt contract here in our Babbage context. So let's go ahead and go back here, and so we passed in that function, and it unlocked the contract, right? And finally, we've just got a description here on 109, redeem a smart contract. And then we console.log the TXID of the redeem transaction. So if everything's going to go well here for me, if the fates are smiling down on me right now, I guess I'll go ahead and run this. And just bear with me here as I do that. So I'm just going to say npm run deploy. And looks like we got an error. It's saying we got to run the script compiler. So, of course, this is just actually something that you have to do with every single sCrypt project you work with, where you sometimes have to say, go compile your sCrypt code like you normally do. So, once again, just a reminder here that this is just a normal, this is just a sCrypt demo project. I've just forked it here and rewrote the main function. So I'm going to run this now, and let's see, we're getting the MetaNet client, and it's asking me whether I'd like to allow my local host to create a Bitcoin transaction. And keep in mind, it's saying there's an output here with no description provided, but it's got 1,000 Satoshis in it. And if we go look back at our code over there, up on line 95, we're actually saying we want 1,000 in the output. So we know that's the same actual transaction that we were creating here. So I'm just going to approve it, and just like that, okay, it's running still, and there we go. So that code is finished running. So let's actually have a look at what got printed in the console. Firstly, we said it said deployed, and it gave you a TXID. So that's actually a TXID on the Bitcoin SV blockchain. And I'll put, I'll copy this into the description or something like that. You can see it. But so if we look at our console log, right, that makes sense, right? The console log on 99, it said deployed TXID, and then we went and called list. And then at the end, once we got our list back with all of our contracts in it that were hydrated using that hydrator function, that got console logged on 103. So let's look at that. We see listed, and there's an array of objects, right, being logged to the console. And each object, it's got some things on it. It's got an amount. It's got a thing called a transaction envelope. And that's not too important, but we've got an output script, and we've got the number of Satoshis, we've got spendable, the TXID, the output index, and then we've got this contract. So it hydrated the contract. The actual sCrypt contract instance is actually physically here in the returned list item. And it's got all the fields on it, such as the hash that we created, hash of hello world in SHA-256, I believe is that value there. And then afterwards, the next thing is our redeem. So if we look down here, we called the redeem function. We went ahead and passed in our redeem transformer, and then we console.log that on line 111. So this is really cool. This is the beginning of a lot of stuff. This is just the beginning. We're just now getting into this stuff, but we can now create a contract. Firstly, we compile it here just like normal on line 91, and then we go ahead and create an instance of it. We deploy that contract onto the BSV blockchain, and we provide a little description. And then we log that. We go and get a list of the things that are currently in that basket, because we deployed it and we stuck it in the tests basket so that the Babbage wallet, the MetaNet client, would know how to keep track of that particular contract that we just made. So we put it in the tests basket. Then we listed all the contracts in that basket, hydrating all of them with the sCrypt information, as you can see here, from the locking scripts on that line there. And then we went ahead and we actually redeemed the contract. So the only couple things you might be wondering about are, what are these strings, right? We got a string here, the contract that we deployed. It says deploy a smart contract, and then we have redeem a smart contract. So those are the descriptions that we would provide to the deploy function, the redeem function, that actually describe what we're doing. And where does that show up? Well, if I zoom out here again, and if I go to my MetaNet client, let me just click up here to the top right where my MetaNet client. So MetaNet client just sits in your system tray, by the way. It kind of leaves you alone when you don't need it. So localhost, if I click here and I see this, well, looks like I've just made a couple of transactions, 3 minutes ago. And it says the first one is called deploy a smart contract. That looks familiar. And here's the TXID. That's the same TXID we just saw before. And that's my Bitcoin transaction with all of its inputs and outputs. And then right after that, we redeemed a smart contract. So you can see coming in, we redeemed a custom token, incoming 1,000 Satoshis that we successfully unlocked. And then what we didn't pay to the miners and transaction fees, we actually got back into our own MetaNet balance. And that increases the balance up here. So that's how that works. Creating an sCrypt contract with, and this could be any contract, but this one's really simple. With these functions here, and then actually redeeming it and doing so in a way that any app that you give permission, when you actually run this code, you'll have to give it permission to access this tests basket, which is this thing that you can just have particular contract outputs stored into. But any app on your system can interact with that with your permission. So you, as the user, hold the keys to this. You can facilitate the access to this type of information, these tokens, this contract within your applications. So pretty powerful stuff. And in the next video, I'm going to be going into a little bit more depth, maybe some technical depth about, we're on line 90 here when we start to define our main function. So there are 3 functions, the deploy, the list, and the redeem function. And I'll go into detail about how do those actually work to let you deploy, list, and redeem your sCrypt contracts using the Babbage SDK. But this is just happening today. We just got this working today. I just wrote this code today. This is very early. This is just the beginning. This is going to be really great. I'm super excited about the future of what's going to be possible with all of this stuff. So definitely stay tuned. We have a lot planned on the horizon with sCrypt. We think sCrypt is a great platform and a great language for people to write Bitcoin SV smart contracts. And we're really excited to start integrating this into a lot of the tools that Babbage has been working on, including the MetaNet client and the identity infrastructure. So definitely stay tuned. Look out for the next video where we're going to be talking about how does that actually work, and maybe we'll write some cooler smart contracts too that have a lot more features. Thank you very much for watching. Oh yeah, and by the way, we'll be showing how to integrate this into a web front end as well, so you can have it in a Babbage app. So you can write an app that does the contract, and it's like a website and everything like that. Kind of like how I guess Panda Wallet does. Anyways, thanks for watching. Catch you next time. Stay tuned. Bye bye.